Good morning, calculus students. Let's get ready for an example of proving one of the memory facts of differentiation for a trig function. And in preparation, let's recall the quotient rule, where we assume both a function f and a function g are differentiable with respect to variable x. Okay. Then if we are trying to take the derivative with respect to x of the quotient f of x over g of x, again we use the quotient rule, and two things we talked about in class: the derivative of this quotient is another quotient, but the denominator of the derivative function is the square of the original's denominator. And the derivative of a quotient, and we say this kind of silly in class, but it's the difference of two little products, f prime of x times g of x minus f of x times g prime of x. So it's the difference of these two little products, and in each product there's one derivative. Here's the first one is where you take the derivative of the numerator. Okay. So again, we'll need the quotient rule to verify some memory facts, the derivatives of some trig functions. Okay, I'm going to move this paper. Hope that doesn't make anyone seasick out there. Okay, so in class we reported that the derivative of the tangent function with respect to x is secant of x times itself, or secant squared of x. Okay. To verify this memory fact, we use a quotient identity from trig, and there's several of those. We might get a list out, but we're going to use a quotient identity that if you have tangent applied to an input, you can rewrite that tangent function as sine of that same input over cosine of that same input. So if the argument of tangent is the variable x, then the argument of both the sine and cosine functions are the variable x. Okay. So equivalently, or equivalent to taking the derivative of tangent x, is taking the derivative with respect to x of sine of x over cosine of x. So that's step one to verifying this memory fact. Okay. So we look over at our quotient rule, and we had started out taking the derivative of this general quotient. The original denominator was g, so the derivative's denominator is g squared. So the derivative of our quotient with a cosine in the denominator has a derivative with cosine squared in the denominator. Then we go back to our rule, and I'll tell the reader what I'm about to do. I'm going to take the derivative of the numerator, leave the denominator alone, and then subtract the original numerator times the derivative of the denominator. And let's double check that. Up here, the first product was f prime times g. That's the derivative of the numerator times the denominator. Derivative of my numerator times the denominator. Okay, so that's looking good. Now let's actually take the action of differentiating sine. Leave the second factor alone. We'll subtract this next product, leaving sine alone, but seeing that we need to take the derivative of cosine, which is opposite sine of x. And we don't want to forget, as we simplify, that that factor of -1, I may even highlight that here in the demonstration. We need to remember that factor of -1 is there. Okay. So then real quickly, let me tidy this up, and you can look at and think about the reasoning here at the end. Cosine times itself can be rewritten. -1 times a negative will make this a sum. 'So I'm adding sine squared in the numerator. write down my denominator. And then what I want you to think about or look back is that we can use a Pythagorean identity. And if you apply cosine squared to an angle and add sine squared of that same angle, that sum always simplifies to 1. So check the Pythagorean identity. And then to finish out our verification, remember what we wanted to verify? We wanted to know that the derivative of tangent is really secant squared of x. So we wrote tangent as a ratio, as a quotient. Now we've ended up with a ratio or a quotient down here. But since the reciprocal of cosine is secant, then the reciprocal of cosine squared of x is secant squared of x, and our fact is verified. Thanks, everyone.